They are composed of numerous tailor-made components that are produced by a variety of manufacturers and assembled by the National Aeronautics Space Agency and NASA at their headquarters in Houston. The first spacesuits were introduced during the 1950s when space exploration began. They have evolved over time, becoming more functional and complicated. Today, NASA has 17 completed EMUs, each of which cost over $10.4 million to make. The manufacture of a spacesuit is a complicated process. It can be broken down into two phases of production. First, the individual components are constructed, then the parts are brought together in a primary manufacture location, such as NASA headquarters in Houston, and assembled. Helmet and Visor Assembly 1. The helmet and visor may be constructed using traditional blow molding techniques. Pellets of polycarbonate are loaded into an injection molding machine. They are melted and forced into a cavity, which adds the approximate size and shape of the helmet. When the cavity is opened, the primary piece of the helmet is constructed. A connecting device is added at the open end, so the helmet can be fastened to the hard upper torso. The ventilation distribution pad is added along with purge valves before the helmet is packaged and shipped. The visor assembly is similarly fitted with headlamps and communication equipment. The life support systems are put together in a number of steps. All the pieces are fitted to the outer backpack housing. First, the pressurized oxygen tanks are filled, capped, and put into the housing. The carbon dioxide removal equipment is put together. This typically involves a filter canister that is filled with lithium hydroxide, which gets attached to a hose. The backpack is then fitted with a ventilating fan system, electrical power, a radio, a warning system, and the water cooling equipment. When completely assembled, the life support system can attach directly to the hard upper torso. The key components of the control module are built in separate units and then assembled. This modular approach allows key parts to be easily serviced if necessary. The chest-mounted control module contains all of the electronic controls, a digital display, and other electronic interfaces. The primary purge valve is also added to this part. The cooling garment is worn inside the pressure layers. It is made out of a combination of nylon, spandex fibers, and liquid cooling tubes. The nylon tricot is first cut into a long, underwear-like shape. Meanwhile, the spandex fibers are woven into a sheet of fabric and cut into the same shape. The spandex is then fitted with a series of cooling tubes and then sewn together with the nylon layer. A front zipper is then attached, as well as connectors for attachment to the life support system. The lower torso, arm assembly, and gloves are made in a similar manner. The various layers of synthetic fibers are woven together and then cut into the appropriate shape. Connection rings are attached at the ends, and the various segments are attached. The gloves are fitted with miniature heaters in every finger and covered with insulation padding. The hard upper torso is forged using a combination of fiberglass and metal. It has 4 openings where the lower torso assembly, the 2 arms, and the helmet attach. Additionally, adapters are added where the life support pack and the control module can be attached. All the parts are shipped to NASA to be assembled. This is done on the ground where the suit can be tested prior to use in space. The individual suppliers conduct quality control tests at each step of the production process. This ensures that every part is made to exacting standards and will function in the extreme environment of space. NASA also conducts extensive tests on the completely assembled suit. They check for things such as air leakage, depressurization, or non-functional life support systems. The quality control testing is crucial because a single malfunction could have dire consequences for an astronaut. The current EMU design is the result of many years of research and development. While they are a powerful tool for orbital operations, many improvements are possible. It has been suggested that the spacesuit of the future may look dramatically different than the current suit. One area that can be improved is the development of suits that can operate at higher pressures than the current EMU. This would have the advantage of reducing time currently required for pre-breathing prior to a spacewalk. To make it can be in the resizing of the suit in orbit. Currently, it takes a significant amount of time to remove or add extending inserts in the leg and arm areas. One other possible improvement is in the electronic controls of the suit. What now requires complex command codes will be done with the push of a single button in the future. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.